Now that we understand the similar triangles within right triangles, let's talk really quickly about geometric mean. Right now it doesn't seem related, but it is. The geometric mean of two numbers, a and b, is the positive number x such that a over x is equal to x over b. So notice, when we're talking about mean here, we're not talking about average, we are talking about the means of a proportion. And in this case, the means are the same number, hence a mean. So let's look at a couple of quick examples here. What is the geometric mean of 18 and 14? Well, using our definition, to find the geometric mean, that's the number x such that 18 over x is equal to x over 14. Notice that x is our means in this proportion. It is both of them at the same time. To solve this proportion, we are going to use the cross products property of proportions. When we multiply our means, we get x squared. And when we multiply our extremes, we are going to get 252. Now, how many of you remember from your algebra how to undo a square? Hopefully you remember that that is by using a square root. So the square root and the square undo each other. So on the left-hand side of this equation, we're left with x. However, 252 does not have a perfect square root. So we're going to have to take a look at that and see what we can find. I'm just going to come over here and I'm going to write down a bunch of factors here. We know that there's 18 times 14 because that's how we got 252. We have 1 times 252. We have 2 times 126. Oh, this could go on forever. Oh, I know. Instead of looking at these ones here, because they're not going to be very helpful to us, we're looking for things with perfect squares. So 4 goes into 252. 4 goes into 252 63 times. That's good. 9 goes into 252. 9 goes into 252, let's see, 28 times. What's the next one? 16 doesn't go into it. 25 doesn't go into it. 36. 36 goes into 52 7 times. Oh, guess what our largest square is that goes into 252? So we are going to use the square root of 36 times the square root of 7 as the square root of 252. And of course, we can now take the square root of 36, which is 6, and we can't take the square root of 7, so we'll just tack that on the end there. So the geometric mean of 18 and 14 is 6 times the square root of 7. Let's try this next one over here. What is the geometric mean of 15 and 27? Our definition says that it has to be the means of the proportion 15 over x is equal to x over 27. Now we'll use the cross products property of proportions and multiply our means and our extremes. When we multiply our means, we get x squared, and when we multiply our extremes, we get 405. And of course, how are we going to undo that square? We're going to take the square root of both sides of the equation. So the square and the square root reduce each other. We are left with x is equal to, oh my, I'm going to use some of my handy-dandy math skills, and I'm going to tell you that this is the same thing as 81 times 5, because 81 times 5 is 405, so the square root of 81 times the square root of 5 is equal to the square root of 405. And of course we can take the square root of 81 now, which is 9. We can't take the square root of 5, so we'll just leave it. So the geometric mean of 15 and 27 is 9 times the square root of 5. Do you see the difference between the geometric mean and the algebraic mean? The geometric mean is not an average.